let's go ahead and see the U-substitution for integration. So this is another technique of integration. If you have, let's say, composition of functions, then you can use this rule to find its integral. For example, here, I see this is being composed into this function to the 6th power, and there is a function right there. Well, what is this really representing is that you have some function and its derivative appears in the integral. So it's kind of like the chain rule of the differentiation. So if you have, let's say, an integral of the form, some function f of x composed with g of x, and the derivative of g appears in the integral, then you pretty much come up with the substitution. You'll add this piece right here, just the inner function, to represent u. We're using u for convenience. You can call it any variable, really, to be the function g of x. Then when you take the derivative of u respect to x, you get g prime of x. Now, what we often do is we just multiply both sides by dx so that we have this exact format. So another way to write this would be to write du is equal to g prime of x dx. So your integral is now rewritten in the form of u variable. So you will have the integral of f of g, well, g is representing u, times du, because g prime dx is du. So that's how you rewrite the integral. And once you have that, you can use power rule of integration to carry out the integration. So that's what we're going to do with this problem. So I'm going to pick this right here. This is the inner function. It's the piece that I'm going to select u to be. So u is going to be 3 plus x to the 4th. Now check this out. If I take the derivative respect to u, derivative of 3 is 0. Derivative of x to the 4th, that's 4x cubed. Now we tag along the x. Now you see that this does appear in my integral, but it doesn't have the 4 in there. So I need to modify this. So what I'm going to do is I'm going to divide both sides by 4. So I have 1/4 du. So keep it consistent, right? I'm going to put 1/4 du is equal to x cubed dx. So now our integral u is going to be replaced with 3 plus x to the 4th, and du 1/4 was going to be replaced with x cubed dx. Now, this is our first example here. So I'm going to rewrite the integral a little bit nicer. Suppose you have the integral of 3 plus x to the 4th to the 6th power. And I'm just going to push x cubed right here. Since it's multiplication, I can move terms around. This is x to the 3 dx. Now you should clearly see that this is your u, and this is your 1/4 du. So rewrite them in the u variable. So this is equal to the integral of u. Well, that's being raised to the 6th power, so just write it out. Times 1/4 du. So I made the replacement. Now, because 1/4 is just a constant, we know that can also be pulled out from the integration sign, because integration is linear. It satisfies the linearity property. So this is 1/4 the integral of u to the 6th times du. Now here, you should recall the power rule of integration. So the power rule of integration says that if you have an integral of the form x to some power n dx, it's x to the n plus 1 over n plus 1, of course, plus c, assuming n is not -1. That's the power rule of integration. That's what we apply here. So my power is 6, so I add 1 to the power. This is 1/4 from before. Add 1 to the power, and then the same power goes on the bottom, plus c. And then just rewrite. So this is going to be u to the 7th over 4 times 7th is 28 plus c. Now, once you finish integrating, don't claim that's your final answer, because your final answer should be in the original variable that the question was stated. We need to go back what u is right here. U is 3 plus x to the 4th. So sub that in. Our final answer is 3 plus x to the 4th to the 7th power over 28 plus c. That's the final answer. So even here, this is not the final answer because it's in the u variable. Always go back to the final substitution. All right, so for this problem, we'll do the same thing. It looks like we can use the U-substitution because whatever you select U to be, the derivative appears on the integral, and I can see that already. You should see it too. So let U be equal to just this portion right here because it's composed with the square root. So I'm going to select that to be U, just x cubed plus 13. And then if you take the derivative with respect to x, you'll get 3x squared. Derivative of 13 is 0. Tag along the x. So now my integral, so I'm just going to rewrite it for you this way. You have the integral of x cubed plus 13, and then there is a x squared outside. Now that's a silly to write, but let's just say like that, and then dx. So my du will replace this piece right here, but then I don't have it 3, so that means I need to divide through. So this is 1/3 du is equal to x squared dx. Now I can make the exact substitution. So I know that this is replacing u, and this is replacing 1/3 du. So my integral in u variable, it's going to be the integral of square root of u times, now 1/3, you can pull it outside the integral, du. And write it in a power form since we only know power rule for integration, u to the 1/2, because square root can be represented as a power of 1/2. Then using the power rule of integration, we add 1 to the power, and then the same power goes on the bottom. So this would be 1/3 from before, u to the 1/2 plus 1, that's going to give you 3/2. This would be u to the 3/2 over 3/2, which is same as writing 2 over 3, reciprocating that, plus c. And then we just multiply these numbers. This is 2 over 9, u to the 3/2 plus the constant c. Now plug in what u is. Well, this is u, so I'm going to sub that in there. This will be 2 over 9 u, that's going to be x cubed plus 13 to the power 3/2 plus the constant c. So there is our answer to this problem. So this is the last example we want to work out. Here's another integral where you're going to use U-substitution. So again, we are going to select u to represent the inner function of this piece. So it looks like we have this function raised to some power 5 on the bottom. So I'm just going to select u to be just the inside of that. So let u to represent 1 minus 6t. This is in the t variable. You want to change it to x, feel free to do that. So the derivative of u, so derivative of 1 is 0, derivative of negative 6t is negative 6 dt. Again, instead of x, we're using t, so dt instead of dx. Now, the integral doesn't have a negative 6 in there, it's just dt. So I'm going to go ahead and divide both sides by negative 6. That gives us negative 1/6 du is going to replace dt. So u is going to replace 1 minus 6t, and negative 1/6 du is going to replace dt. So our integral is going to be, so dt is replacing negative 1 over 6 du, and 1 minus 6t is going to be u, so that's u to the 5th power. And now this is a constant, so you can push it outside the integral. We have negative 1/6 outside the integral of du over u to the 5th. Now this doesn't seem like a power rule yet, so I want to bring that on top, which will make it into a negative exponent. So negative 1/6 u to the negative 5th du. So just allowing us to use the power rule in this form. Now let's use the power rule. So when you integrate x to the n dx, this is x to the n plus 1 over n plus 1 plus c, assuming n is not negative 1. So using the power rule of integration, we add 1 to this power, and then the same power goes on the bottom. Okay, so we have negative 1/6 outside times negative 5 plus 1, that's u to the negative 4. Same power goes on the bottom, negative 4, plus the constant c. And now just clear things up. So negative 1/6 times negative 4 on the bottom, that's negative positive 24, and u to the negative 4 plus c. Now, if you want, you can make this exponent positive, and that would be the preferred way of writing our answer. positive exponent. So this is simply 1 over 24 times u to the positive 4 plus c. And now let's substitute what u is. So if you go back, u is right here, 1 minus 6t. That's where I'm going to replace on the bottom. This is equal to 1 over 24 times 1 minus 6t to the power 4 plus the constant c. So that is our final answer for this problem. Okay, I hope this makes sense. See you next time.